All right, so we're good? All right. How does it feel?
Oh, I'm used to it, Sam.
Okay, so let's talk about schedule, because as the case with this class, I'll probably be bringing this up very frequently throughout the quarter. There's a lot happening. There are a lot of due dates to keep up with. So plan for today, we're going to continue lecturing about development principles. Tomorrow we have our lab, and we're going to be doing kind of a Git procedure. We're going to be learning all about Git, so try to keep up with all of the intro Git. The kind of the deadline for that is tomorrow, so that you can talk about it. I'm going to want you to be working in your groups collaboratively as part of, basically I have a site, a tutorial site for branching itself. I will also be talking about the requirements for interfacing with Git for the scope of the quarter-long project. So that's the plan for tomorrow. Thursday, we'll be back in here, probably doing some more of this lecture. And then next week is really the official start of the 2-week sprint. I will have the rubric up for the first sprint, as well as all of the requirements by the lab period tomorrow, so that you can also, as you are learning Git, start to talk to your team about who wants to do what, start the planning process for the sprint. But the actual 2-week period begins Sunday night. And that marks the 2-week period before the deadline of the first sprint.
I know you explained.
Yeah, we'll go into a little bit more terminology, but a sprint is basically it's very much like a sprint. It's when you're gonna start, you're gonna go crazy hard at the requirements that are there and the deadline approaches, and you have some kind of deliverable. The idea is that your project isn't in a partway complete stage. You have something to deliver. You have a deliverable for the project. And unfortunately, with just the scope of how the quarter is set up and how our labs are set up, the day that you're going to have to show this to the client is the lab day before, the week before it's due. So you really have a week and a half to get things into a state that is at least showable. It will not be graded on that. It's mostly just a presentation to the client that says, hey, we did what you asked. We have a couple things left to tweak before it's finalized, but this is our idea and our plan. Do you have feedback? And the client will say, this is great, or this is almost what I asked for. And then they're also going to come up with, wouldn't it be cool if, and set you on the road for the next sprint. The other thing that's on the schedule coming up is a quiz that is a week from Thursday. I think that still makes sense as the appropriate time for that quiz. My goal by the end of the week is to get you at least a study guide with some elements to it of what might show up on the quiz. I don't like to go into too much detail on those, but it's very similar to other classes that you might have had with me. I'll give you a list of topics, and your task will be to go through all of the associated content that we've covered and the book is covered about those topics, and anything about those topics may be on the quiz. In general, I can also just talk about my quiz design. I try not to have lots of memorization types of questions, terminology types of questions. I will have you applying something or talking about your perspective on something, which makes it a little bit harder to grade. But rather than just being, what is this term? What is this idea? It'll be, how is this idea used in practice? Why is this particular idea important to the development of? So questions that really make you think and give me an answer that is not just there's a right answer and a wrong answer necessarily, but it's how much have you thought about how this idea interfaces with the field that we are going into.
What is the pace of how we should be reading the book?
So we had the discussion yesterday from the first chapter. Next Monday, or can I say this Monday? I can probably say this Monday now that it's 6 days away. 6 days from now, we will have a discussion on the second chapter of debugging teams.
So should we just plan that every Monday we're gonna talk about the new chapter?
It's on the syllabus. If we go through the syllabus on each week at the bottom, there's on each week, it'll say like debugging teams or DT chapter 1, DT chapter 2. The Monday class of that week is the week that you should have the book read by, we'll have a discussion. I may table some of the discussions I feel like the first one was very important because it really set the tone for the rest of the book and how we should be thinking about reading the rest of the book. But I will do it for the second chapter, and then after that, we might start to skip one or two, depending on the pace of the class, what we need to cover to be ready for the actual material that's going to be in the Sprint Sprayer project. Other questions or concerns about the schedule, what's coming up, how to prepare for what's coming up? There are a lot of things to be aware of, so I'll at least at the start of each class ask, is the schedule clear, or if there are any new things to be thinking of? Here are the things that should be on your radar. Last time we were in here, at the end of last week, we started talking about software development principles, the actual process for how you can develop something from start to finish. We talked about the waterfall model, which was a big deal in the 70s and 80s and has since been used as part of current processes, which is why we still study it, but we can at least dive into why does or doesn't this work just by itself. So remember that the waterfall model by itself just says that each stage, basically you have a linear progression from one stage to the next. We don't iterate, we don't ever go backwards. We don't ever consider anything about the past when we do the next stage. So this process, you start with gathering the requirements from the client. What is the scope of this project? Let's actually just go back through the slides that we talked about just real quick to get a sense of how to visualize it again. Gather the requirements. So we're gonna talk about the features. What does this application need to be able to do? What are the boundaries? What are we filling it in with? Just getting an idea of what are the components of this project. We then create the specification. So we're going to go from these kind of vague requirements to an actual technical document that describes what we need to do, what the system is actually going to be able to do. What are the exact boundaries for what is a part of this project and what is not. Design, here's where we're going to find how are we going to accomplish the specification. So what technically do we need to do to be able to produce this piece of software? So now we can kind of divide up this project into its components. And each of those components have technicalities associated with them. What is the technology we're going to use? What's the architecture we're going to use? What are the modules? We need to define the modules. And how are these modules going to communicate with each other? So what are the interfaces between the modules? By the end of this, we should know how the system is going to work in addition to exactly what it's going to do. This allows us to split it apart and different developers to work on different modules within the scope of this same project. This allows us to specify, there's kind of a line here specifying that these are separate components that will communicate with each other. There might be another line here and another line here. So then we actually go implement it. So we actually go write the code that is going to be the project. So code it up. Even as we're coding, we still need to come up with a plan for that coding. That's not part of the design necessarily or the specification. It doesn't specify how we're going to be writing the code. So we need to plan the coding procedure. We need to figure out the order in which we're going to be tackling these modules, as well as what does it look like at the end of each sprint. So it might be that this doesn't end up looking like something like this at the end of the first sprint. Maybe this just looks kind of like an outline at the end of the first sprint. But again, that's not really part of the waterfall module. We just do it. Palpatine benefit. As we do it, we test each module, make sure that it's working to what we want. We then integrate. Once all of these modules are coded up, we have each of these modules working independently. We integrate them together into the final product. So you've maybe written some unit tests for these modules, but now we need to test the system as a whole, as the entire product. We haven't been able to do that as these individual modules, because as we said before, this piece needs to communicate with this piece, which needs to communicate with this piece, and that's impossible to do while they're in development. Once we integrate the pieces together into the whole, then we can actually have these communications and we can actually test them and make sure that each piece is doing what it's supposed to in the scope of the entire project. Finally, we ship the product. It's hopefully pretty close to what the specifications said. Maybe there's a little bit that we couldn't quite get to or was technically impossible given the constraints of our time or budget. And we need to maintain this software, make sure that it's usable, it doesn't break, there aren't any bugs with it. As we get those bug reports, we may be responsible for fixing those bugs, start maintenance. So here's where we are. Moving forward from here, note that there was testing with every single phase. So we need to verify the requirements. That's not a unit test, but it's something that we need to go test with the client to say, do we understand these requirements correctly? Is this everything that you wanted us? Think of it kind of like the contractual part of the negotiation with the client. We need to test the specification to make sure that the specification is everything that we need. We need to test the design, maybe research, is there better architecture or technology that we could be using actually justify the use of the design that we're using. Of course, we need to test while we code. Of course, we need to test while we integrate. So one way we can think about this is we have a top-down design for this. So the requirements are the most abstract component. Has nothing to do with the technical content of the code that you're going to be writing. We start from the abstract and we slowly get more and more concrete and specific at each one of these stages. And then once we implement bottom up. So we start with the most specifics and then we integrate the subparts. That's more abstract than the actual coding of the module. And then we integrate the product all together, which is more abstract than coding each individual line, each individual module as we do that together. So the first half, the design path, is top down. The implementation path is bottom up. Looks kind of like a U. Let's move into some discussion about this. So risks. What can go wrong if you were to just use this model exactly as it has been shown in this set of slides? What could go wrong? Yeah.
What comes to mind is the meme you showed about the tire swing.
Yes.
It's what immediately comes into mind.
What part of that though? What particular set of pains, whatever those are called?
Every single point of failure that can happen.
It can still happen there, sure.
Because if it all rolls downhill, then if it starts bad, it's gonna end bad.
Yeah, absolutely.
I don't know if this goes along with what he's saying, but it sounds like it, what if you need to like back up or what if whatever you're doing is just bad and you can't like backpedal or fix
It
it?
seems like there might be something during design or during implementation, you go back and you say, the specification doesn't tell me exactly how to do this. According to the waterfall model, we're not allowed to do that. We can't go back and edit the specification after we've moved past the specification phase.
It's like a high commitment sort of thing,
Yeah,
better work otherwise.
yeah, it means the planning is very important. We have to think of everything before moving on.
It's just, it's like going off what you said, it's just very black and white.
Yeah. Yeah, this was taught early on in computer science history as this works by itself. So major risks. We need to be able to assess the requirements at the very beginning of the project. The requirements can't change from the start of the project. That means the client can't change their mind. That means that new technology as it comes out during development can't be used. We can't iterate, we can't figure out and change anything about the requirements. We don't get any feedback about people who are actually going to be using the product until the product is ready to go. If You hand this to the client uses it and says, this is really clunky. I don't like this font, I don't like this scope, I don't like how I can't zoom out, I wish that I could do this. And they're usability concerns, it's not something the client was even aware of when you gather the requirements from them at the very beginning. So it would be nice to be able to send them the specification document and to have them be technically savvy enough to be able to understand that specification and say, yes, of course, this is exactly what I want, or be able to poke holes in it. And say, I think the final result from what you described here technically isn't going to play well with my users. Usually clients don't think that. You put something in front of them and then they're dissatisfied with it. They don't think about how they're going to be dissatisfied with it from a specification document. If you have issues with the specification, if it's not specific enough, it may not be found until you're coding it or integrating it and you realize that you don't know what you need to do. It can take a long time before you have a first working version. In fact, it can take a really long time before you have a first working version. Wouldn't it be nice if you could test things out and make changes to this whole process based on the tests, the kind of the QA tests, the quality assurance tests that you have on your own project? If you don't have intermediate builds, then also as an engineer, you can't see your work developing. Yeah, there are more lines of code, but do we really consider that to be progress? We're visual people, usually, most of us. It's nice to be able to play around with the product as we build the product and we see the new features that we're adding to it actually be something that we can interact with. So it's a big morale boost if you have those intermediate builds where you can see and feel and play around with the progress that has been a part of your every working day for however long it's been. And then finally, it's sequential. And each of these processes are very specified in terms of who is actually working on each one of these components. You would be hired as a programmer. So you're gonna be a part of the implementation or the integration phases. Until we get to that point, what are you doing? You're just waiting. You're waiting for someone to hand you a specification. And either you're being paid for doing no work, which sounds great, but what positions actually do that? Or you all become temporary employees who have to be hired for specific projects at specific times. You don't necessarily work for a company, you just are working for yourself. So all sorts of risks and issues with the model. Where do we think this comes from? If you were to kind of go back in history, and why would this design make sense? Where does it come from?
I could see it coming from the time when you had to like ship something on a CD or like a floppy disk where someone has to put that in and that's just it, you know?
Yeah.
Where it's like finite point of transfer.
Yeah, that's a very solid point, right? You actually ship something and it had to be complete. Like using my own example, because I'm the game design person, it used to be that, you know, you had to have a complete final game that got shipped on a disk. There was no downloadable content, there wasn't patching. You couldn't have a game be incomplete and be changed. You had to, it was done when it was shipped.
I would say like maybe architecture, just building houses.
Yes, that's actually exactly where it comes from. It's borrowed from engineering. How is it that you build a bridge? How is it that you build a house? It follows exactly this waterfall type of pattern, where you need to figure it all out before you start, because once you're in the middle of building the bridge, there's no time to go, you know, now that we've spent millions of dollars on this bridge, I think we should scrap it all and we should start over and maybe build it this way instead of that way. Yeah, that's a great idea. That doesn't work in engineering with physical goods. But digital goods are very different from physical goods, and we have different limitations, and we also have hopefully a process that makes more sense given the fact that we're producing digital goods. So it is adopted from other fields of engineering. Very little software is actually built using the exact waterfall process. there are some good aspects to it. So there's something to learn from this as we move forward with these ideas, figuring out what is the agile mindset, what is agile development, what does it look like? So we know that we want to actually spend time designing a specification and actually writing out a specification, going through the design phase, making sure that testing is happening all the way through. Communication through documents. There's actually a physical representation of what needs to be done. So we can't just have a squabble between two teammates. We need to do this. No, we need to do this. No, we need to do this. It's in the specification for exactly what you need to do and how you need to do it. So you can always refer back to the technical documentation to avoid that kind of useless confrontation. So time is a big problem in software engineering. We talked a little bit about this last week about how there's kind of a race to market. Your company has a really good idea that it wants to monetize and use that as an eventual product. As you have that idea, some other company has that idea. Or maybe they had that idea a few weeks ago and they're already in the process of development. So taking time is risky because if you're not the first to market, you're missing out on getting people on board using your product. People don't like to switch between using different kinds of products. They don't like it when their phone's interface is completely changed. Who in here has switched between using an Android device and an iOS device for their phone? Not very many of us. It's happened. Have you switched more than once? Did you go back? So yeah, most likely you stick to one model, and as there are updates to that model, it's less to learn and interface with than it is to play around with what are my options. You find a favorite and you stick with it. That means that, let's say that you're developing the next big phone operating system. How good does that have to be to take everybody in this class and make them switch over to your new model? There's a lot of learning, there's a lot of risk that has to happen with that. So getting traction early on is what's going to create that success. Because of that, as you're a developer, you're going to get a lot of time pressure. Other reasons time can be a nuisance. The world changes, especially in this field. New technology all the time. New ideas all the time. New optimizations all the time. You start something and it's obsolete before you even finish it. Of course, other people produce competitive software, so you want to produce something that's better than theirs or newer than theirs or is out before theirs. Lots of third-party components, lots of library integrations. So you're going to be using other software that other people have written. So compilers, for instance, any networking libraries that exist. You don't want to write your own, of course. You don't want to write your own operating system to use that. So all sorts of software that you are using as you develop. We get new ones all the time. So it's worth keeping up with the current technology. If you don't move very quickly, you end up trying to keep up with all of the changes that are happening around you, and it can be difficult to balance actual productivity with the planning of, hey, look, this new great thing came out, how can we incorporate that into our project? That's a way to never finish anything. I love this really old case study because it actually comes from the use of the waterfall model. So this California DMV software was produced based on the waterfall model, not based on anything that has happened since then. So the idea behind the software is we have driver registration systems and vehicle registration systems. Drivers and vehicles were completely separate, and I wanted to merge these together into one nice database registration integrated system. The planning, when they went through that process, was that this will take 6 years and $8 million. And in reality, they stopped even trying after 7 years and $50 million of investment. So it was a completely failed project after a ton of time, a ton of money, when $50 million is a lot today, but I mean, go back to the early 90s, how much money is $50 million after inflation from the early 90s? So cost significantly more than the initial estimates. The expected delivery slipped all the way to 11 years after its completion before the plug was pulled on it. So that's really tough. It's tough to be able to not go back to those early parts of the model and be able to change them because the world changes around you. And has been for some time, very outdated example, but this is a very outdated model, so it's fitting. Questions on the waterfall model? So this is actually a 5-part slide deck. We're going to be talking about development through the course of 5 different slide decks. So we're moving now on to one of the big issues with the waterfall model is we couldn't go backwards. We couldn't loop this process. So we're going to start talking about what is it like to develop iteratively. So the waterfall model is really slow. We could speed things up by looping the waterfall model and then reducing the requirements that is necessary to move to the next phase. That way, when we release something, we actually deploy some code, it's not the fully finalized, finished everything, but it's the first prototype or the first design. We can now get some feedback on that, start the process over and iterate. So in the very short term, the world's not going to change, at least not too much. But if we're fast, planning isn't quite as necessary. We don't have to plan for the far future, just the immediate future. So waterfall model, very slow. The idea behind rapid prototyping is we're going to design the simplest possible workable product. It's not going to have any unnecessary feature. Any feature that is there, you're gonna have links that go nowhere. You're gonna have menus that are blank. You're going to have, if it's not needed, it's not there. All you need is the bare bones prototype to get feedback on it. So what does that bare bones prototype look like? Once you code up, go through one process of this and have something that you can show, here's the bare bones prototype. You're going to show it to people. There's almost nothing here, but what do you think of it? As you get that feedback from those users, you can then go back to the requirements and say, all right, I'm going to incorporate that feedback into the next iteration of the design of this product. Once we do that, we proceed, as in the waterfall model, going through everything. We don't use the prototype anymore. We are going to completely code from scratch whatever it is that we added from the showing it to user step. So we go through all of the specification, design, coding, integration, final product. Some comments on this. It's really difficult to throw away something that we've worked on. That's tough. However, it gives us a significant leg up when we go to determine those requirements. It means that we have a lot more and better information. A prototype will also tell us what we did wrong. And as you, I'm sure, have seen as you code, if you try to change something that is broken, you more frequently end up with disgusting spaghetti code that takes a lot longer to fix than it does to start over and just produce the right thing, given the knowledge of the mistakes that you made the first time. The fact that you actually went through that process to build that prototype is going to introduce you to some of the tools that you're going to be using. So a lot does carry over from the prototype to the actual development because you will have interfaced with the technologies that were required to build the prototype. Of course, there are some issues with this as well. We need feedback between all of these stages. We can't really just, here's a prototype, give it to people, go through one waterfall and have the product. So we need some feedback between all of these stages. So think of it like, instead of a wall or waterfall, think of it more like, I don't know, salmon on the locks, where there are all of these stages, but sometimes as they're falling down, they can, go backwards or hop back up, or the goal is sometimes to hop up the stages between one or the other. So as we write the specification, we'll figure out, we don't know something about the requirements, or something needs to be clarified about the requirements of the project. We can't finish the specification without further knowledge of the requirements. As we go to design it, we'll find holes in the specification, or even if we want to modify the specification because the design says maybe someone had a really good idea about the design, which changes the wording that we should use in the specification. We don't want to not go back to the specification because it's already been written if the goal is to have the best product that we can. You hire some programmers and it's taking too long. Maybe we want to be able to go change up the design a little bit based on the fact that it's taking too long to implement. Or there's a new technology that we want to use, or we determine in the middle of coding that we can improve the complexity of one of the associated algorithms and the implementations from this, from the original, what the design said that we should be using. So we should, of course, go back and change the design as we come up with the better solution. As we have a final product and we send that to people, they're gonna say, that's not what I wanted, or I wanted this instead of that, or something else that might require it to go all the way back to the requirements and change the initial requirements. So we're gonna start talking about, okay, we have feedback loops within the waterfall model. When should we be thinking about allowing ourselves to do that? Because if the exact opposite end of that spectrum is that we're never going to create a final product because we're always iterating and trying to improve a product, ever releasing the product. So just accepting that as we're in a later stage, we may need to go back and make changes to earlier stages. Plan to do so. And the idea is that you want to minimize whatever we can quantify as risk. What decisions may need to be changed in the future? Plan for how can we figure out what it is that we need to do as quickly as possible. So confirmation and reputation can come from a bunch of different levels. That could be as a programmer talking to your manager. From the manager's perspective, talking to the highest up or the client directly, or whatever needs to be done to figure out exactly what you should be doing to move forward. Here's kind of a visual for what this might look like. You have some very initial planning, maybe even creating a prototype, and then you're just going to enter this circular waterfall that never really finishes. You just end up with the first deployment, the second deployment, the third deployment. Every one of these is a new version of your program or your project as you've gone through this whole process of planning, gathering requirements, analyzing, implementing. Eventually, you finally have the next version of the product that you can release. And then you immediately start testing from there and evaluating and going back and making the next version. Or the next build. Plan to do this multiple times. This is exactly what we're going to be doing in this class. We're going to be doing this loop 4 times. So the project itself is broken down into a series of builds. The very first build is going to be a minimal prototype, and each next build will be adding more features, refining the requirements as the requirements change. And you will find that in this class, these requirements will be changing on a sprint by sprint basis. There will be some added features that you were not aware of that you will be asked to do. Let's go through these actual phases as before and talk about how these change from the waterfall model. So requirement gathering is exactly the same as before. We still need to talk to users, talk to the client, figure out what is it that we need to do, recognize that there are diminishing returns for this. Eventually, after spending 3 weeks straight talking to the client, you're not getting any new useful information anymore. There reaches a point where it's no longer worth having that back and forth, and it's worth getting started, taking the information that you've gathered and moving on and producing something from it. Do note, though, that if you don't have something to hand the users or hand the client, that you may not be able to understand all of those requirements, and they may want to add some things to those requirements as they start playing around with what you've developed. So, it still looks exactly the same. We go on to the specification. We still want to actually write this down and document what the system does in all circumstances for all inputs in every possible state. So think about every possible state this application could be in. It is worth spending significant time on, but do note that this specification is going to change as we iterate this process. So now instead of a PDF, an uneditable PDF, now we're producing some kind of shared document that will be updated over time. Move on to that. On to design, we're again gonna decompose the system down into modules, but now instead of just designing the system, we want to design for change. So those of you who took design patterns from me, and probably those who took design patterns from somebody else, this is where those come in. We want to make sure that we're expecting parts of this system to be changing as we move through this process over and over. So design the code and the requirements such that they're going to be changing and make it as easy as possible on future you and the developers who will be part of this project on the next iterations to make those associated changes, because you're not going to be aware of them when you're writing this code for the first time. So put abstraction where things are likely to change. That abstraction is mostly in the form of design patterns. We can still decompose, specify the interfaces. Still looks like this. But now we have incremental change. So I mentioned before how we might have outlines of these triangles rather than the full triangles. The very first time you're developing, just create skeletal components. It's going to start with just the very bare bones of the product. And as you iterate this over and over, you will slowly start to fill this out. So at the end of sprint 1, at the end of build 1, maybe your product looks like this. Then you start doing something like this, where you will start adding some functionality to one of the modules. And then you will slowly add some more to it. And add some more to it. Depending on what the project is, depending on what this will look very different, but this is the general idea of how you want to start thinking about the project, is that we're slowly going to be adding functionality over time. What to think about in the very first build? You just want a minimal system, a skeletal system, something that is functional. It does as much of the project as you can with minimal functionality. So everything is there, but they don't do very much. But do note that the interfaces are implemented, which means that we know the boundaries between these components. We know how the communication is going to be handled between those components, but they don't actually do any of that communication. You're creating the ears and then blocking them so that we don't need to implement exactly what that communication looks like. But we know this component's going to need to communicate with this component. So we'll implement the functionality for that communication without adding the communication. This allows you to build a complete system, develop the individual components separately, and you end up with an actual skeletal build. After that first build, what's nice is you always have something to show your client or your team, boost morale for this. So after build 1, you have some demo. Here's the skeletal demo. Here's after the next sprint. And then maybe this is just a 2-sprint system. So every single build, just add however much functionality you can get in the next sprint. I'm kind of moving this toward agile as I go. We'll talk about this more in detail. But the integrated test for every single build, you'll just integrate with what's currently available. And that gives you a nice stabilization or release point where the product does everything that it can do right now. And then just continue to do this until you have a last build. And of course, you can ship earlier builds. I again like to go back to the games example because most people know about this, but this is where you start to ship the alpha. You start to get some alpha testers and some feedback. Eventually you move into beta and you can start shipping a beta version of the game. And it's not to release point yet. It doesn't have everything that you're planning for, but it has enough functionality to get useful and meaningful feedback and to start generating some excitement about the final product. Some advantages of this, we get early feedback, which is great. It allows us to take that feedback and put it into our design. We also figure out, is the specification and design that we've initially made even feasible? Is this something we're going to be able to do in the first place? If the answer is kind of no, or we start to get that concept, we've overscoped this project, we can start having those kinds of discussions for future builds. It's also much more quantifiable. In the waterfall model, when we're in the implementation stage, we don't really know exactly how far we are into the project. There may be some significant roadblocks that we've already been aware of yet that will delay the project for years. But if we're iterating this process and we are at build number 3 of 4 planned builds to get everything working, we know we've gone through 3 of these cycles, we have 75% of the features. Maybe we're not quite 75% done, but we have an idea that we're closer to 75% after 3 of 4 builds than after 3/4 of the waterfall stages. Of course, we also have some disadvantages. You can make a major mistake in the requirements specification or design phases. And because we didn't really spend as much time thinking about this in advance like we would have in the waterfall model, maybe that leads to making a major mistake because we didn't do enough planning. Note that we're also beginning implementing things before we fully refine the requirements, before we fully finalize the specification. So as those things change, you open yourself up to creating spaghetti code as you want to start changing aspects of the design. This is why putting design patterns in large scale projects is really important because it minimizes the chances that you're going to be creating that spaghetti code and creating large scale problems as you go try to gut existing code and make significant changes to them. If it's been designed for change, then that process is much easier. Unfortunately as well, if you're being slow, the downside to being faster is that we do a lot of studying the problem in the abstract. You have something that's working and we're trying to figure out how is this going to work, and we don't do that full planning before we actually start doing it. There are pros and cons to that. So I don't know, this is kind of an advantage and a disadvantage at the same time. There are trade-offs. So software development in practice uses some kind of iterative model. A lot of companies use daily builds. Whenever changes are made, they get interfaced, and every day, whatever functionality gets added to it is just something that becomes part of the fully online product. So something like Microsoft Outlook, for instance, has a daily build associated with it. Yeah, Microsoft does this for almost all of their products. You don't have massive updates to most Microsoft products. It's just that you sign in today and things are a little bit different than they were yesterday in one small area because there are daily builds always online, always working. There are some systems that are really difficult to be iterative about. As an example, we have unmanned space probes. So we actually do have to resort to more of a waterfall model. on some things that, you know, you ship and you have no ability to change after you ship them. So there still are some examples, like the old video games, of development that needs to adhere to something more one-time than iterative. I'll just kind of leave this summary up there as I ask if there are questions about iterative design. Why this, kind of the pros and cons of this compared to the waterfall model. It isn't really different, it's just kind of an upgrade to the waterfall model. Yeah,
So with any of these two designs, at what point we have a contract with the client? So we spend this time and money and energy on this process and we have somebody to buy it.
that's very company dependent. There's not a set time in this that makes sense. It would probably depend on a lot, what is the product? You would want to say something like, you will pay me through the skeleton prototype. I'm gonna show you the prototype and then we will agree on what the next sprint looks like and the cost for that. But of course, you don't want people pulling the plug after they've already paid you money when they say, you know, that is too expensive. So maybe you can come up with a price ceiling that says, we won't charge you more than this. Or you will say, here are all of our processes. We'll break this down into the man hours of our programmers, break this all down and say this is the cost of utilizing our system. It'll take as long as it takes to produce this, but we can put it in this estimated rate. I'll give you an estimate for how much it's going to cost. And I'll come back to you for the okay for, all right, we have these components, but to finish these components, we need more time. It's gonna cost this much more. Or there are lots of different ways that you can handle that kind of negotiation. Usually that's outside of the scope of the actual programmer's responsibility, but it is an important part of this process to make sure that you do have a legal contract for everything that you do. You don't want to produce a product, they haven't paid you or have made a legal statement that they will pay you, and then you don't get paid for it. That would be the worst case scenario from your perspective. All right, we are out of time for the day. Tomorrow's lab, we will do some Git prep. And Thursday, we'll be back in here, finishing off these last few sets of slides about the agile development process. And most importantly, figuring out how to communicate with each other, what you're gonna do. And what? GitHub, the site that hosts it in the language that is associated with the whole thing. This is the place.
Product's already done, guys.
Like the version that's
Oh, I like it. So rare is. Sure.